Alright, so this is our first of 3 lesson videos on chapter 17. And so today we're going to cover the first 7 slides, so get your notes packets out and let's go. So chapter 17 is on non-renewable energy resources. So here we're mainly going to focus on fossil fuels. Alright, so human society depends on energy. We need it to grow, store, and cook our food, to warm and cool our homes, to extract and process natural resources like mining for gold and things like that, to manufacture items and transportation. And so we have these huge energy needs and we have to meet them somehow. And so in this chapter we're going to focus on how we meet them using non-renewable energy resources. So as the word tells you, it means we cannot create more of them. So per capita consumption of energy is much higher in developed than in developing countries. So again, those rich countries like the United States, we use more energy per person than a poorer country. In developing countries, which are the poorer countries, industrial energy use is lower, but household energy use is higher because they don't have quite as many efficient options as we do. Developed nations use more, but consumption is not increasing and is relatively stable. So even though in America we're using more energy, those developing countries, they're eventually going to get to that point where they're using more too. Whereas in developed countries, we've kind of plateaued and we're kind of using about the same amount. And so if you look right here, this is the per person commercial energy consumption. And for once, the United States is not the highest. It's actually Canada. But we're in a close second, of course, right? So one of the things that we use that's non-renewable is coal. Coal is the most abundant fossil fuel on Earth. The U.S. has 25% of the world's coal deposits. So we like to use coal because it's readily available. It's used to produce electricity and steel, which we use especially in high-rise buildings. There's 2 basic types of coal mines. There's surface mining and subsurface mining. So surface mining is coal within 30 meters of the surface. So in other words, we're not going really deep. 60% of our coal is obtained through surface mining. It's usually safer for miners because they're not really deep underground. It's less expensive because, again, it's closer to the surface. But it disrupts the land extensively because they just clear huge areas of land to get to this coal. Subsurface mining is deep underground. Approximately about 40% of our coal is mined that way in the United States. So what are some environmental impacts of coal? Oh my gosh, there's a lot. So, substantial effects on the environment. Coal is one of the worst fossil fuels we can use, but yet we love to use it. So it has topsoil loss from erosion or removal during mining. So again, that land that we mess up when we mine, it ruins the soil. And so of course then plants can't regrow there and succession can't happen as well. So it prevents the restoration of the site. So again, like I said, succession can't happen. Plants can't grow if the soil doesn't have enough nutrients. Acid and toxic mineral drainage leaches from minerals exposed to mine waste. So there's a lot of this acid and drainage that happens in the mines, and of course that goes into water sources, goes into the rivers, and eventually goes into the oceans. So streams become polluted with silt runoff and what's called acid mine drainage. That's kind of what I was just talking about. Sometimes they do mountaintop removal, where they go to the top of the mountain, they get all the coal out, then they cut lower, get all the coal out, and then they cut lower, and so they're slowly removing the mountain. This is one of the most destructive mining methods because, one, you're destroying the mountain, but the sides of the mountain, the valleys and the streams, those also become polluted with all of this mine drainage and things like that. We have already leveled 15 to 25% of mountains in southern West Virginia through this method of mining. Half the peaks in that area will be gone by the year 2020, which, what do you know, that's right now. Remember, our book's a little bit old. Valleys and streams between mountains are obliterated. They're filled with the tailings. So in other words, when they remove all that dirt, it has to go somewhere. So they're filling in these streams, and of course all of this waste is dumping into them also. So what do we do with the coal when we get it? Well, we burn it. All right, that's what we do with all our fossil fuels, is we burn them, and that's where all those emissions for greenhouse gases and things come. So it contributes to more air pollutants than oil or natural gas, which we'll talk about both of those. When oil is burned, it produces sulfur and nitrogen oxides, which those are the 2 things that make our acid rain. So which react with water in the atmosphere and cause acid deposition. Remember, that's just another word for acid rain. It releases more carbon dioxide into the atmosphere than any of the other fossil fuels. Okay, so it's causing acid rain, it has more air pollutants, it releases more CO2. So far that's 3 strikes against it. Scrubbers and other technologies can be used to remove sulfur and particulates from emissions released during coal burning, but again, that's expensive. So we have to keep that in mind too. But we really like it because when you burn coal, you get a lot of energy. So oil and natural gas, they provide 56% of the world's energy. In the U.S., it provides about 56% of our energy. Other sources that we use is we like to use coal, 23%, nuclear power, which we'll talk about later, 9%, renewables like hydropower, wind, and solar, we'll talk about those in the next chapter, 11%, and liquefied biofuels, 1%. We'll talk about those later too. Oh, apparently we're having an
Abby
announcement.
Maxey, if you are still in the building, you're needed in the front office. Abigail Maxey, please come to the front office.
Well, hopefully she made it to the front office. All right, and so this is just the percentage of world's commercial energy production, and it's broken up between oil, coal, natural gas, renewables, and nuclear. And like I said, we'll talk about all the rest of these in this chapter or the next. All right, so petroleum or crude oil, you'll hear it called both things. Those are liquids composed of hundreds of hydrocarbon compounds. So we talked about hydrocarbons already. It contains hydrogen and carbon. It's usually a long chain molecule. So petrochemicals, oil is also used to produce fertilizers, plastics, paints, pesticides, medicines, and synthetic fibers. So when you turn oil into something else that you can use to create these, that's when we call it a petrochemical. All right, and then natural gas. It only has a few hydrocarbons, and so one of them is methane. It's used primarily for heating residential and commercial buildings and generating electricity. But we also use ethane, propane, and butane. Like you might have bought a butane lighter before or something like that. Liquefied petroleum gas would be like propane and butane. They're separated and stored in pressurized tanks as a liquid. So you can take a gas and compress it and then liquefy it and store it in a tank. Because as you can imagine, gases sometimes are a little hard to store. So if you liquefy it, then that helps. All right, so we'll stop here for now and I'll cover some more in our next video.